Good evening, all of you. Today we are going to see our fifth practical assignment, which is the case of pure conduction. We will see a composite slab having three sections, each of length 100 mm, subjected to temperature. At first, it will have a temperature of 400 Kelvin. At second, it will have a temperature of 600 plus twice your roll number. Let's say my roll number is 50. For thermal analysis, we will require one material property if it's a case of static steady state conduction, which is thermal conductivity. First section will have a thermal conductivity of 45 in 45, 20 and 45. Here, as we are considering the dimensional unit as a mm, we need to divide this thermal conductivity by 1000 so that it will be it will match our unit system. Now go back to answers. In the preference, we will choose thermal so that it will update the setting as per thermal analysis. First task is to add element type. Here we are going to add a link element which has the conduction capabilities. Click OK. To define the area of that particular element, we have to go to the real constant. If you remember, the structural link don't have feasibility to define the area inside the real section. We define that in the section tab. So now we will define the area as my roll number is 50. I will input half of my roll number, which is 25. Click OK. Material properties. In material properties, we will define two models, which will be thermal conductivity isotopic. First will be 45 divided by 1000. And second will be for the second section. New model. New model 20 divided by 1000. Click OK. So we have two material model defined. Now go to modeling, create three key points located 100 mm from each other. Apply. Now second point will have 100 mm its coordinate. Third will have a coordinate of 200. Apply. And fourth will have a coordinate of 300. Now simply create the lines. First segment, second segment, third segment. Now here, as we know that the second segment has different material properties. So before meshing it, we have to choose the attributes. Meshing, mesh attributes, thick line, and here only just change this material number to 2. The rest will be same as that is. Click OK. Now mesh this structure. Now I'm going to choose 10 elements per segment. So I have to input here 10. Click OK. Call back by click on resident and then simply mesh it. Now we are ready to apply boundary condition, which are nothing but the thermal loads. For that, go to define loads, thermal temperature on key point. This key point will have a temperature of 400 and second will have 600 for twice the roll number, which is 600 plus my roll number is 50, so it will total will be 700. Click OK. Now simply solve the problem and go to post processor, plot result, control plot, nodal solution. So as you can see that there is a gradient in between. So this is your pit practica. Here we will not require much more details as it's a simple case of conduction.